Hello and welcome to my talk on setting free the developer from the boilerplate. I'm Seb Carss and I'm a Principal Systems Engineer at Shop Direct. I've got with me Liam Chadwick, who's a Systems Engineer at Shop Direct, and he's going to be driving for me today because we're going to be doing a live demo. So at Shop Direct, we're moving towards microservices at the moment because we understand that microservices will give some great benefit to our customer. Microservices allow us to deliver great value to the customer really quickly. So obviously we want to be moving towards that, especially when we've got a monolithic application at the moment that when you deploy to it, obviously it's the entire application. You just want to change a tiny little piece of it, a little bit of functionality. You have to deploy that whole application. With microservices, you can just deploy a tiny service, which is the whole point of it. So as a software house, we are looking at trying to get to frictionless development. That's a great term, isn't it? Frictionless development. I love that. It basically means getting the developer to go straight into adding value to the customer without having to set up any boilerplate beforehand. So at Shop Direct, we've been working to do this, and that is what we're gonna show you today. So first, what is microservice boilerplate? I'm going to say Microsoft at one point because I keep saying it. What is microservice boilerplate? So in a nutshell, I suppose a microservice is a discrete service that returns some data for us, in a nutshell. But to do that, we require some sort of application. Something that has dependencies, libraries, things like that, and obviously is set up in a code management sort of tool so we can obviously get other developers working on it. Once we've actually got that application, we then need to get it out to production. We need to deploy it somehow. So we need some sort of CI pipeline. And this CI pipeline will have a battery of tests, obviously, and include something where we can set up that deployment, that microservice, as an image that we can store that is immutable, maybe like a Docker container or something like that is also portable. And then eventually deployment to something like cloud infrastructure, some way of hosting for our users. That can be as complex or as simple as you want it to be, but we need something there. So that's what I mean by microservice boilerplate. So what is the problem with microservice boilerplate? Well, as I've said, there's an upfront cost. That comes from creating all of that for a microservice. And you have to repeat that over each microservice you create. And of course, as developers, we know that we don't repeat ourselves. We've got an acronym for it, so we shouldn't repeat ourselves. So obviously, we want to automate as much as possible. This ultimately leads to a hit on productivity. And this productivity is for the developers because they end up writing configuration instead of writing code, which actually delivers value. So that's inefficient. And ultimately, that leads to slower delivery of value to our customer. It's still quicker than using, trying to change a monolith, but it's slower than it could be. And that's the whole point. We're trying to optimize this. Our customer doesn't care about microservices. Our customer cares about getting a dress delivered next day so that she can go out with her friends and look good. Our customer cares about getting a washing machine delivered and being able to pay for it on 3 monthly installments so you can spend more time with the family. Our customer doesn't care about microservices, but we do because microservices allow us to get that great value that our customer wants out to them quickly. So at Shop Direct, we've been looking at this problem, and we've been trying to figure out how we can remove that upfront cost so we can make our programmers more productive than they already are and actually deliver value more quickly to our customer, which ultimately leads to frictionless development. There it is, that brilliant term again. So I'm going to set myself a challenge. So my challenge is to build an entire microservice using the Spring Boot framework with all the libraries and all the dependencies I've talked about during this presentation. But I'm not going to stop there. I'm also going to build an entire cloud infrastructure which will automatically scale my microservice based on demand, will balance load across all the services, will manage and monitor containers dynamically, the containers that store my microservice, and I'm not going to stop there. I'm also going to plumb this whole thing into a CI pipeline, which involves unit tests, code quality tests, acceptance tests, load tests, and automatic deployment to production. But I'm not going to stop there either. I'm also going to deliver value to the customer, all in 30 minutes. So you guys are going to be my customers today. And by the end of this, I want you all to be able to get your phone out, go to our microservice, and actually have some value added to you. So first, we need a service. So a little bit about me. I'm a big foodie. I used to be a chef before I was a programmer. And one of my favorite dishes that I like cooking is ramen. So for those of you that don't know, ramen is Japanese noodle soup. And the problem I have with ramen, apart from eating lots of it, is finding it. Because I live up in Liverpool. In London, you guys have got loads, so it's great. But up in Liverpool, we don't have that many. So I wish to have a ramen locator service, something that would actually locate ramen restaurants for me. So that's what we're going to create today. We're going to create a microservice that has a simple GET request with the endpoint of /locate. And the response that we get back is a JSON response with a list of ramen restaurants nearby with their longitude, latitude, and some ratings. And at the end of this talk, I want you guys all to be able to find ramen from your phone. So that when you go home, you've got a nice walk home, you can find some on the way. But something to say about microservices before we move on to this. This is just data that's coming back. It's nothing special, but it's what you do with this after. So with a microservice, you get this data back from this microservice, and then you can get maybe some sort of UI or some application set up off the back of this. So you could plug all this into some Google Maps, and then you could find your location. Or you could do some other wonderful things for it. But that's the point of microservice. It allows you to just get some data back nice and quickly, and ultimately do what you want with it. So, Liam, can you go to the Amazon instance, please, and go to Bitbucket and create as a new repository. So we're just going to create a ramen locator repository. So this is going to store all of our code. And once you've done that, can you run the create microservices script, please? So this is just a store for all of our code, so developers can actually start working with version control. We then run a create microservice script, which I'll just run through what this is actually doing. But basically, it takes a microservice template that we've already got, which is pretty much a full microservice that we've set up with all the libraries and all the dependencies, and it's already stored in Bitbucket as a microservice template. So we take that, we pull it down to our local machine, and then we push it up to our new Bitbucket location. So that allows us to basically do the first step of my challenge, which is to build an entire microservice. So that's good. Step one done. So the next thing we do, in fact, actually, sorry, can you go back to Bitbucket and can you just refresh? So this should now pop up magically and say ramen locator. Microservices template. So as you can see, we have just copied that completely. It's a very simple task. Obviously, there's a lot of things that have gone on in the background there to actually set up that microservice template. But in this case, we're just doing pretty much a copy. So now we've done that. The next step is to actually build a cloud infrastructure. That's the second step of the challenge. So we use AWS for this, and in particular, CloudFormation. And if you've not used AWS before, as developers, I implore you go out and have a play with it. It's absolutely brilliant. Even just from a self-development point of view, it's fantastic. But what we're doing here, as you can see, if you could just go to the Resources tab and then maximize that, please. So in here, this is the AWS CloudFormation template. And what it allows us to do is CloudFormation allows us to build cloud infrastructure from code. So we have a file, a YAML template file, that says which resources we want to build. And in this case, it looks like there's 4, but there's actually a 5th one, but it's dependent on a couple of the others. So this is getting built now just from a file that we have that we've actually stored with our microservice template, which means it's all part of the same build. If all the world sort of fell apart as after we've got all this set up and running, we can go and grab that same build and build the infrastructure up exactly as it was before. So I'm just going to jump back to the presentation, so explain the sort of resources that are being set up here, the stacks, because it's a bit easier through a presentation than from that screen. Okay, so the first thing that we're building up is a container registry. So this is basically like Docker Hub. It allows us to take an image of our microservice, a container of our microservice, and push it up to this ECR, to this registry, which will then allow us to tag it, and it's now an immutable object that we can now pass across as many servers as we want. But the beauty of that is it's not going to change. So you might want to just check. Sorry. So that's basically the ECR. The next thing we create is a cluster stack. So the cluster is really just a name for a logical grouping of container instances. And in this case, we have them over a couple of availability zones. So in AWS, if you don't already know, an availability zone just spans different areas in, like say, for example, in Europe, in a region, which allows us to spread our instances out to different places so that if one fails over for any reason, we've got the other one still working fine. So it adds some really good resilience for us. The next thing we create is a container service. So the container service really is the brains of what's going on behind it. This allows us to manage our microservices, manage our tasks that are running. So in the picture there, the T represents the tasks, and that is basically our microservice. That's that Docker image that's been up in the ECR, pulled down, and it's now running on our instance. The A stands for agent. So in each of the instances, we have an agent running, and that basically talks back to the service. It tells the service what the health is of those instances. So things like CPU, memory utilization, what tasks are running, how many tasks are running. And when it needs to, if, say, for example, one of our tasks falls over, then the service will know that we really want 2 tasks running. So it will get rid of the old task, and it will pull down from the task definition the repository, the Docker image that we want, and it will now rerun that again on that task. So it's a really good system. Like I say, it's the one that actually sets up and manages our microservices. Next, we have the ELB, which is the Elastic Load Balancer, and this is a fairly simple stack that gets created. It just manages the load across all of our services, across all of our tasks. So in this case, if you've got 2 users hitting the ELB and you've got 2 tasks, in theory, they'll go to each of the tasks. And the final thing we create is an auto-scaling group. And this kind of hugs around all of our instances within our cluster. And this is really, really important for us because the auto-scaling groups allows us to add rules that will define what happens when we have peak periods and sort of low periods. So what happens is you can set up a rule to say, based on CPU usage, if the CPU usage goes above a certain percentage for, say, 15 minutes or what, then it will add 2 more instances, and then it'll add more tasks to that. And by doing that, it allows us to bring that CPU usage down, give a better experience to the customer. And this obviously works really well at high peak times. You know, from our point of view, things like Black Friday, that works really well because we can scale it up massively and then scale it down quickly. However, it works really well during the day as well because we can incrementally scale up and down throughout the day during the peak times, and that can save a lot of money. So that's basically all the stacks that we're creating. I hope that made sense. If it doesn't, then we can maybe chat later about it. But I hope that made sense. So if we can go back and see if it's all up and running now. So the microservice, so the CloudFormation has now completed, and we've actually got a running instance of our microservice. So we're just going to show you this with an endpoint that we've got called version. If you just maximize that, please. So as you can see, this is now a running instance that we've got. So that's stage 2 of the challenge, to actually build an entire cloud infrastructure. As you can see, it currently says microservice template. That's not what we want. We want it to be Ramen Locator. So in the background, after it had done the create microservice had finished doing the CloudFormation, it also went through and changed all of our references within our code base, within the microservice template, to Ramen Locator. That includes all of the class names, the packages names, things like that. Everything we need to completely switch it over to being our own service now. So it then pushed that up to Bitbucket for us. So Liam, if you could just go to Bitbucket and just refresh that, please. So as you can see here, it has actually changed everything to Ramen Locator for us automatically. Now, ultimately, we want to get this completely streamlined so it just runs with one click, with one service name. but it's a work in progress, and this is where we're up to so far, and it's pretty good. So the next step, obviously we've now got this RAM allocator set up, but we now need to push this out using a pipeline, which obviously we haven't got yet. So Liam, could you just run the register CI pipeline, please? So this is, again, another script that we run that allows us to register the Bitbucket repository that we've got with our with Jenkins. So Jenkins can then poll our repository every minute or so to actually see whether there's any new changes. And if there are any new changes, it will then pull them in. So depending on how lucky we are, this could be quick or it could be a minute long. I say we, I mean me. So while that's running, I will tell you what it's going to do.
You have to clicking scan multi-branch pipeline.
It'll kick off in a minute, don't worry. So yeah, what it's actually starting to do is we've got a Jenkins file that's within our microservice template. And again, this allows, like the infrastructure, it allows us to put our Jenkins file, our pipeline, into our build. And that means it can change as we need it to. It can be updated. It's always going to be there and ready to go when we need it. And one of the things that we say about this as well is we're not prescriptive on this. This can change. The pipeline can change as and when we need it. One service this is a template. It's not the solution for everybody. So we're going to create a starter for 10 for everybody to get that value to the customer as quickly as possible, and then it's adaptable afterwards. So as you can see, it's now kicked in, very delayed today. And the first thing it's starting to do is pull the code down from the repository. After this, it goes on and runs the unit tests. Again, this is all just baked into the microservice. So we use JUnit for our unit tests, and all the libraries, all the dependencies are there in our microservice template. And not just that, we actually have unit tests already there. So we have that /version, the endpoint that you saw before, that's all got unit tests around it, which means from a developer point of view, as soon as you get your microservice, you've already got code there that not necessarily shows you how to do what you need to do, but gives you a starter for 10. After that, we run code quality. So the code quality we use is SonarQube. And SonarQube is a really good tool because it allows us to check for technical debt, to check for code coverage, to check for duplicate code, and also, really importantly, bugs and vulnerabilities. So there's some security checking in there as well. After that, it goes through and does acceptance testing. So the acceptance testing we do is using Cucumber. So for those of you, I'm sure you're all aware of Cucumber, it allows us to do BDD, which gives us some nice humanized tests using the given, when, then syntax. So again, all this is baked in, and we can just get started on it straight away. After the acceptance test, we do load testing, and we've got Gatling as our load testing software. So that's all set up and ready to go. And that basically goes through and performance tests. It really hammers our microservice. And what it's checking for is degradation of the service, just to make sure that if it is starting to degrade, then we can start looking at why is it starting to degrade. So after the acceptance test, it goes and does a bake and push. And the bake and push is what I was talking about before when I talked about ECR. So this is where we take our microservice, we bake it into a Docker container, into a Docker image, and push that up into the ECR, tag it, and then we've now got this immutable and portable container that it will never change, and therefore we can pass it out to lots of different servers and always get the same result. After the bake and push, we end up doing deployment. So this is where, if everything's gone green so far, we get an automatic deployment to production. So that's basically the CI pipeline that we've got set up. And like I say, it's a Jenkins file that we can change as we need, but and it's in the microservice template, but it gives us a really good start for 10. So while that's waiting, because the deployment will take about 2 minutes, just going to show you something else we've got in. So in fact, actually, I'm going to talk about the fact that we've got the 3 stages pretty much complete now. So the first one, obviously, is the setting up a microservice. The second one is the cloud infrastructure. That's now set up. The third one is the CI pipeline. That's pretty much, it's set up. It's just we're waiting for it. But that means right now, I don't know how long the time's been, but it's not been long. And we've actually got to a point where we can add value to the customer already. We can start writing code and being productive again. So let's do that. So Liam, can you go to IntelliJ and do the copy some code over? We're going to cheat slightly. Obviously, we're going to put some code in that we made earlier, because otherwise we'd probably mess it up. So we've got some template code, really, that we're just going to pass in. And then we're going to get you guys to get involved and help us out with some more code. But ultimately, the point is we can actually get to adding this value in right now. So once this is all started, we'll get to it. So in here, we've got a Ramen locator. So there's a locator resource. And for those of you that know Spring Boot, you'll see already what we've done. But there is a request mapping set to /locate. So obviously our endpoint. And on our method, we've got the request method of get. So we know that we're going to be getting that method when we go to /locate with a get request. So what we've done here is, it's very crude code, so I apologize about that. But I've created some restaurant locations. And there's 3 at the moment, but I want a 4th one. So can I just, has anyone got a name of a ramen restaurant, or make one up? Pho. Okay. Pho. It's actually Vietnamese, but it works. It works. It's fine. I'll go with that one. And it's pronounced pho. Sorry.
Not a foodie.
I love. Oh, it's gorgeous. I was hoping I can get one for breakfast, but nothing seems to open till 12. So anyway, we've actually added that in now. And can we build the application and run Spring Boot application locally? So one of the good things, obviously, as part of this microservice template is we've got all of the testing baked into it, like I said before, which means we can actually run all of our unit tests and everything, right on within the system. Which means before we do any deployment, any push to master to our remote repository, we can test it all locally. So if you can just go to the Swagger UI. So another thing we've baked in, before we go back to see the deployment, another thing we've baked in is Swagger UI. So for those of you that don't know, Swagger is a way to build API documentation from our code automatically. So we didn't have to write any of this page. This is just given to us because we've added Swagger to it. And it does simple things like sets up the fact that we've got a GET request with /locate, and it gives us the values, the example values of what you're going to get back. So things like a latitude, which is going to be string and stuff like that. And this is really powerful for when your end users are looking at what does this microservice do. They can look at this page, the Swagger page, and determine how can they use that information. So that's what it's really for. And if you just scroll down and click on the try it out, and then scroll down again, we should see our ramen restaurants there. This is the response we should be getting, and you can see Furs there as well. So that is what we're expecting you guys all to have on your phones at the end of this talk. So can you just go back to Jenkins, and hopefully it's all deployed. Hey. So can you go back to the version, and just refresh? So this is in production. This is all ready. We've now changed the service name to Ramen Locate. Nothing major, but the main thing is we've completed those first 3 tasks, and we now have a completely ready Ramen Locator service. This is now ready to actually add some value. So Liam, if you wouldn't mind pushing that code up to Bitbucket, please. So what we're going to do now is just push this up so that Jenkins will now pick up the new changes we made, run through all the tests, and then deploy everything. And in the meantime, while we're waiting for that, because it will automatically pick up in a bit, but in the meantime, while we're waiting for that, if we can just go to Grafana, deploy to Grafana as well once you've done that. So this is the last thing we've added in. We talked about monitoring before. So we've got there's a great tool called Grafana, which we now deploy our microservice to, and it allows us to see all of the instances that are running, basically do some monitoring for us. So you can see here we've got 2 running tasks. We've got the desired tasks as 2. Like I was saying before, if any of them drop out, the running tasks will then drop down, but then it'll suddenly pop back up again because the ECS will know about this. And we have the number of instances. We've got 3 there, so we've got some room to auto-scale. If you just scroll down a little bit further, And you can see we've got RAM allocators, memory utilization, as well as the CPU utilization. And you can already see some of the CPU utilization down to some of the builds that have happened. So Grafana is a really good tool for us to keep monitoring everything. So if we just go back now to Jenkins, it should have kicked in. Okay, so Jenkins is all up and running. This is going to take a bit of time. So while we're waiting for this, I just want to say a big thank you for inviting me to this. It's been brilliant. I really enjoyed actually talking to everybody and showing you what we're doing at ShopDirect. And I hope that this has been a good thing for you guys to, you got some value from this. Obviously, later on when we get to the deploy stage, we will get you a URL and you'll be able to go to it on your phone and you'll be able to see the real microservice working for you. But in the meantime, Liam, if you want to just put the presentation back on while we wait for a second, and some contact details. If you want to get in touch to either of us, please do. And obviously, I'm going to be around later on, so come have a chat to me, likewise with Liam. So I'd like to hear your microservice stories as well.